We'll just do this. Hey,
This
it's
is a
Coffee
super
Compiler
small
Club.
thing, so we don't
Hang
need
on,
to. Yeah.
hang on. You're being recorded,
Yes.
and you're going to show up on YouTube within a couple hours. And now carry on.
Yep. 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 So I'm not exactly sure what the semantics are, like how it would work, but from my point of view, I think it is coherent. It's as if you asked another core to do the zeroing on your behalf,
Oh, that might work.
but you don't actually have to burn the core. It's like a dedicated accelerator thingy.
Yeah, I hear you. So the burn the core is not the issue because typically here's the thing with burn the core. Cores are cheap. I have lots. I don't care. I'll burn a core. However, those zeros all show up in that core's cache, which then he has to pump through main memory, which then I have to get from main memory,
Yeah.
which
Yeah.
goes back to the problem that I'm burning memory bandwidth and I'm trying
Yep.
not
Yep.
to.
Yep.
So he has to behave like he's another core zeroing it and give me the cache coherency across all cores without burning memory bandwidth.
Yeah,
Like,
we'll have to
don't
see
write
exactly
zeros
what this
out.
accelerator thing does, but
Okay, yeah, don't write zeros out and then read them back in on
yeah,
another
yeah,
core.
yeah.
That's the thing you're trying to dodge.
Yep. 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 Yep.
Okay. Good morning, Derek. Did you survive Thanksgiving?
It's an easy one in Canada.
Fair enough. Fair enough.
Yeah, just another weekend or weekday, but
Just
it's actually nice because we work with the company is like half Canadian, half US, so lower probability of meetings.
Gotcha. So on like 4th of July, do you go see fireworks for fun just because? It has nothing to do with Canada.
Yeah. Yeah. Well, we have them on the 1st, so it's not too far apart.
Okay, fine.
Yeah.
Okay, so well, you're here. You usually have SSA question things. Did you want to have
Oh yeah,
something?
yeah. I've got stuff. I mean,
I think we're just going to be short people today because it's Thanksgiving, and that's just what it is.
Yeah. Well, that's fine. Yeah. So I don't know if I have that much stuff, but I could probably just keep on going. I am really happy with myself because last night I got my first loop optimization going.
Oh,
Nice.
yes, excellent.
And so basically, the one that I did is if I've got stores, if I'm storing in a loop, like basically figure out that, do the work, switch the fee from being pointing to the memory chain, basically pointed to the value being incremented on sort of both inputs, and move the store to after the loop. And I think that's good. I'm not sure if I have the general case or if I just have one specific case. So
this is an example that I pull up, and I'm going to pull it up again, and everyone here should have seen it, and then you can just tell me to quit. But exactly, I step through one of these two. This is probably this one. Let's find the loop version. That's the if. Here's the loop. Oh, here's the memory version. If you wanted loads and stores in a loop. Boom, 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 boom. Okay, I lied. I had it in my hands not very long ago, and now I am not seeing it. So let me try again.
I can pull up the hand-drawn picture of this graph that I used to figure out what the optimization I thought should be, and we can kind of walk through that and then what I did, and then maybe you can find this after.
I'm like going to shoot Dropbox for being confused here. Something happened. Okay, this looks better. Fine. Oh, do you want I'm sorry, you're asking for the screen share. I'm over here poking at things looking for, here, screen share should be up.
Okay, all right. Let me just Just make this a bit
This.
more friendly shape. And all right.
Okay,
Okay,
I found the one I'm looking for now. So that you go first because you're here already.
Okay, so I have a graph that starts with this, and I do a bunch of stuff, and it ends up a bit smaller. But I pulled this subgraph out of it. So let me just sort of zoom in on that. Can you see it okay?
Yeah, so you have some memory, some X store, a new memory. The store has an address you're not showing, but it's probably related to X because you have
The memory is this. So there's also actually I changed the representation. So now there would be an allocate maybe somewhere up here.
yeah.
And that's the beginning of the chain. I have all my arrows drawn backwards.
Yeah,
so,
that's fine.
sorry.
No, that's fine.
Yeah, so the load would also have, one of these, and this store would have one of these as well. But I'm just gonna get rid of those just to
Okay, so
simpler.
yeah, what I'm missing here, some of your arrows are forwards and some are backwards. So select and
yes.
compose is your half fee or your split fee operation.
Exactly, that's right.
Okay, so you have a one store outside the loop, you're loading, you're adding, what's the second select? You're storing. Oh, is that the back edge? Because you don't have back edge.
Yeah, that's the back edge, yeah.
And that's the back edge of the compose. That makes more sense. And you're missing the address, which we don't care about.
Yeah.
Have the memory edge looping. Yeah, sure. I think I have something very similar I'm looking at right here. So you do yours.
Okay, so the thing that I turn this into is I could walk through the edge changes, but basically, yeah, actually, why don't I do that? Because I think it makes it a bit easier to sort of talk through it. So let me just copy and paste this thing.
I have it in graph format, slides format.
Oh yeah, sorry.
Which I've worked carefully to make it like a little tiny movie, which I need to figure out a better movie technology for slides, but fine, yeah. Right.
Yeah.
Okay.
Yeah. So this is where we started. And so basically, what I do first is all the edges from the load go to the compose.
Yeah.
This is going to go dead. And then the store also goes to whoops.
So back up. So go back again until the load is at the compose and you're not doing anything yet. Okay, right there. What I would do, and I don't understand what you're doing differently, is I would push the load up through the compose. Then it goes up to the select and comes around the back edge of the loop, and you have a second load that goes right after the store. So you have a store load, which is easy to optimize. And you have a second store load, which is also easy to optimize, but I do this as a separate step, like push the load and clone it. So it's like you have a loop.
Move the load up. Yeah, actually, you know what? So this is one of the problems that I had, which is I've done this special case for only if I'm storing on before the loop as well. And then I know what the original value is.
Okay. You don't have to care if there's a store before the loop. The trick is you're doing a load and a store in the body of the loop, and they're not aliased. So if you take the loop as a clock that ticks and the semantics zip around the loop, you can rotate the loop by pushing the load up through the fee at the top, the compose, and you get a clone down each path. So it's just like if you got a control flow diamond, you push the load up into both arms of the diamond. Same behavior, except one of the diamonds is actually the bottom of the loop. So you end up with a load before the loop and the load at the bottom of the loop, which abuts directly to the store. So in the body of the loop, the store load can optimize and the load goes away and you remove the load from the loop.
Right. So I go like this.
Yeah. And make a clone of the load for after the store at the bottom that goes to the other select. Yeah. Yep. That one there. And now you get a second load because you've cloned at the compose, which, right.
And so now another copy of this load goes here.
No, the edge from the store is unchanged because that's a memory edge.
Yeah.
Instead, the load feeds from the store and produces the value for the loaded portions. So the difference here
right.
is that
The
you have a
loaded-
second select and compose. At the top of your original loop, you had one value merging, memory. Now you have two values merging. One is memory, one is a loaded value. So you need a second
right.
compose.
Okay, okay. So basically, this structure goes over here. This is actually not, shouldn't be there. This is keep the old store thing.
All right, and I have a do this, and then I want to show you my pretty version, which is going to do the same thing in sort of a less messy format. But yeah, you're getting there. So it takes the memory edge from the load, and he produces a value for your compose on the right. That's the fall in, and you're still going to have a value of the load on the right for the back edge. So you have two loads; they're getting composed.
Yeah.
You need another select on the right as well, then.
Right. Right. Yes, I need the other select. That is pointing to this one. No.
Well, so right now, one of your selects is intended to be the back edge, and I don't know which one. So if the load that you have going, number 50 is your fall in, then select 39 is your back edge.
Yeah.
And the load that comes after the store at the bottom, because it's taking from the memory state of the store. So load number 50. You have two 50s, sir.
They're all the same number now because I've been copying and pasting.
Yes, I see. Okay, so change one of the loads from 50 to something else.
Okay.
I thought you had an auto numbering going. Oh, here's Aaron.
No. Yeah, okay. So 3E9, that's too big. Okay. All right.
This is like slow going online.
Yeah.
Okay, I'm going to go flipped to my version and then come back to you. And so I'm hoping I can drag more people into what you're trying to accomplish, because I think what you're doing is the right thing. Or people would rather stare and watch Garrick.
Yeah, this is a bit bumbling to watch me do this. I will keep on doing it while you're talking if I can try and.
Well, okay, I'm asking, does anyone else care? Then fine, I'm going to do it. People are waking up. They're like, no, fine. So which is exactly the question. It's hard to say because sometimes it's fun to do it live and watch some guy make mistakes. You understand their issues. So here is the similar operation that Derek was showing with a different kind of a graph. So I have a fee for memory here. It's the red fee, and all my red edges are memory. And there's a load and a +1 and a store in the body of the loop. I'm trying to clean out the load +1 store into basically a register +1 in the loop, no loads and stores in the loop. And this fee, there's only the one, and it's carrying memory on the back edge, and then the store takes it and the load takes from it. Okay, so going one step forward, I'm going to push the load up to the fee. And this is basically what I'm talking about when I rotate the loop one tick. What I'm really doing is I'm cloning the load instead of after the merge, I'm cloning it before the merge. So I end up with two loads and two fees. So the fee on the right is merging the two purple edges from the load. That's the new value that got loaded now before the loop. One of the loads is actually from the back edge, and that's the one on the right. The memory is unchanged. It lost the load use because each load does something different. The fall-in load takes from the pre-fee memory, which is the start of the loop. The back edge load takes from the back edge memory, which is actually the store itself. So I made two fees from one, and I redirected the plus here to point to the loaded value at the fee instead of from the load itself. So at this point, I'm going to relay out the graph without changing any semantic edges. I'm just going to push nodes around.
Okay, so but basically, let me try and understand this.
Okay.
Basically, it goes from being a fee that is about bringing around the memory chain.
Yeah.
And it becomes, there still is one. There is still one that has that job.
And it's
then
never
there's
changed.
another one which is bringing around the value that you were messing with in the loop.
Yeah. And then semantically, what I'm doing here has nothing to do with how the use goes in the loop. It's strictly, I have a load at the start of a loop. I can push it up. Now I have a load from prior to the loop and the clone of the load has to roll around the back edge of the loop. And then optimizations may happen from there, but strictly speaking, I rotated the loop one load's worth of the loop semantics.
Yeah.
And
Okay.
then the profit comes because the load at the bottom of the loop folds into the store.
Yeah, well, this is good because the tricky thing about this pattern matcher to find this was I was finding the whole thing as one big pattern, and it involved doing a graph path search from the tail of the loop to the head of the loop.
Okay, let
to
me back
find
up a notch
those
here.
math operations. So moving
roll.
this load out of the loop, I think it eliminates the need to do that.
Okay, so I roll backwards. This is the red area is my pattern match, which is there is a load pointing at a fee. I have two arms on the fee. That's the pattern. Pushing the load up through a fee means I had two loads instead of one, and a chance to fold one or the other.
Yeah.
Also, sometimes one or the other becomes a constant because you're doing a pointer thing or whatever. There's reasons to shove a load up through a fee. Doing so gives you more precision over a larger span. You can gate it with a profit heuristic here, which says that upon one of the arms of the fee, the load points at a store, and the fee and then the load and the store share the same address. So in this case, the purple it plus 8, the load and the store share the same address. There's a fee I can clone. I make two loads, except because I share with the store, it's guaranteed I'm going to fold one away. That's a strictly profitable operation. Without ever knowing there's a loop involved, I should do that in all situations. So that's what I'm trying to make it clear here. There's no reason to look at a loop. There's nothing about a loop here. It's load to a fee is generally profitable, but not always. Load to a fee where one arm has a store, the same address, always profitable. So I'm going to.
Okay, well, this is great. Yeah. So that's what I was thinking that, okay, I've got this, but do I have it in the, best form? You have the advantage of having thought about this for a lot longer.
For a long time. Yeah. I fell over that one way back in grad school, but I was already a year or two into it. And so I'm going to go one more step where I relay out the graph.
Okay.
So all I did here was I got rid of the dotted red. Here's the people, and I pushed the load, the back edge load to the bottom.
Yeah.
So you can see that it's coming from the store, but it didn't actually change any semantics. It's just a shove around thing. Okay, now that I look at the bottom one, I see the bottom load and the store. I have a clear back-to-back store load combo. They share the same address. Therefore, the load is loading with the store stores. Therefore, I can replace the load with what are the store stores. So the load, the purple load value becomes the plus the store storing, just like that.
Yeah.
Now I
have that. I have that one implemented already.
Yes. Okay. So this set of transformations got me a load removed from a loop.
Yeah. Awesome.
And then the next set is I'm going to go get rid of the store from basically using the same thing. So I'm going to relay out the loop a little bit so it's a little prettier. So you have a clear recurrence on the +1 and a store. Now the pattern matches. The store points to a fee, points to itself. So there is nothing else. Store to a fee to itself is just you're spinning a store in a loop. You can just get rid of the fee, and the store then happens after the loop. And so that means.
Yeah. Nice. That's funny.
Here's Simon. All right. Okay.
Okay. That's a nice one.
Yes, this is the transformation that I show is how I get rid of iterators, Java iterators, which have a memory increment. That they make a new object. That's your iterator. You +1 in the iterator, which is a load increment store in the body of the loop, and so that combination sort of cleans out that thing. So a little relay out and get rid of the dead fee on the memory for store, and then you can see I have a hot loop where I add one and a spin cycle, and at the exit I store the final value of the iterator. Into the iterator object, but I don't have to bump it every time. Yeah,
this is the same result that I get, but it's a nicer sort of atomic set of transformations. So
there is a thing that says when you do these things, try hard, just think about what is the smallest atomic transformation I can legally do here, because it'll apply in more situations.
Yeah. So for fun, I don't know if you want to see the pattern match that I created to actually do this sort of big hairy version of this optimization.
Right. Let me do this. There you go. Yeah, go for
Okay.
it. So that's like you have a different pattern syntax for your closure, but with a little screwing around in the layout, it suddenly becomes similar to the patterns I'm using.
Yeah. So let's see if this is too hairy. Maybe I'll show one or two simpler ones first, and then I'll show this one. Oops.
Oh, that's a good point. I can whip out the C or Java code for this. It's not too bad.
Yeah. So like, here's a pattern match, a more simple one. Remove a trivial fee. This is a compose select pair, but basically I can say when I do this, the node that I'm matching against is just named this by default, and so I can match it here and say we have to be selecting this, so it unifies those.
Yeah. Okay.
And so then I can say if I've got to compose, I'm selecting something, and I'm also selecting this. Then we just take the
value.
The value.
So this is limited to fees of size 2, right?
Yeah. And actually, I added a feature that will fix this problem now, which is I can do sum here and then say
like you have to all the things that you match are all either value or this.
Yeah, exactly. So I would have to,
don't do it now.
So I would have to I know that when I'm creating this pattern, every time it's always had the same ordering. So I've never needed to match this reversed version.
Yeah.
But I guess eventually I can have that. But anyway, so that's an example of a very simple rule. Here's an even simpler one. It's just a fee that's not selecting anything becomes void. Void is my kind of 0, but
okay.
It's a 0 that I know came from the void.
This is like an empty argument fee.
Yeah.
Yeah, fine.
Yeah, this I don't think I ever hit, but I have it there.
Oh, you'll hit it at some point. In my world, I collapse all control paths simultaneously, so I don't have a partial fee ever floating around. In a prior version at C2, when I wasn't doing that, I would get partial fees where I knew this path was dead, and so I only had, there's only one value to select, and then the other one was that the whole fee was dead, or the region was unreachable. This whole path is unreachable on all paths. So the fees are all dead because no one can reach them. They can't select anything.
Mm-hmm.
And so you'd get these empty fees that had to have an empty fee rule. So C2 used to have an empty fee rule. It might still have an empty fee rule. AA doesn't have an empty fee rule because I don't make them anymore. Not that way. When I delete the last path into a fee, I'll nuke it at that time and all of them at the same time. And they're tied to the match for no path in.
Yeah. And in fact, I added some rules about deleting things that might actually be handling this for me as well now. Anyway.
Right. In AA, I went to a separate, if you're dead, you're going to be deleted path. Like my work list has a priority sort on input things thrown on the list. And the first priority is if you're dead, you'll go on the dead list and you're done first. And I don't bother to do other things to you if you're dead.
Oh, yeah. That's a good idea. I don't have any priority. I just make my work list as an actual set and I just take things in any order.
Right. Well, it was my original work list. So the more clever thing I'm doing with AA that's more complicated, and you could argue it's not necessary, is that I do things that strictly reduce the graph before things that monotonically keep the same size of graph but change some property that reduces to things that actually grow the graph, and I have to be very careful I don't in an endless growth cycle.
Yeah. And I saw that and I actually started modeling it, but then I realized that everything I was doing, I think I wasn't sure how I should sort of go between the reduce and the monotone rules. So
I split my rules into sets. There are reducing rules and there are monotone rules.
So for a given pass through the matcher, you first just try the reduces and then the monotone and then the grows right away? Or do you like do a whole phase where you're doing only reduces?
I am not doing the whole phase where I'm doing the whole reduces, and I have thought about it, and I think that's a good idea.
Mhm.
The issue there is that in order to maintain the good incremental time, you have to put people on separate work lists, more than one work list. There's a work list for the reduces and a work list for the monotones and a work list for the grows. And you want to put somebody on all three work lists, and then you pull them off the reduces first, and then you pull them off the monotones. So I need more work lists. I have one. I need to have work lists for everybody. And that's a little bit of a change, but it's actually probably totally useful because the shrink the graph first cuts so much crud out so fast that you get a clean, tidy, like you can have a stupid expansion from input to graph and then just have it get cleaned up immediately. And you only bother to look at the graph post the reduce because that does so much work for making it pretty that it's easier to read. And then your debugging happens mostly at that stage. The reduces are mostly obviously correct.
Yeah.
When you say phases, you mean phases of looking at one graph node, not that you're going to do a global sweep of the entire graph doing reduces and then switch to a different method.
No, we are talking about that. So it's incremental. So when you say global sweep of the entire graph, there would be only the set of things that have already been known that they need to be inspected. So it's not everybody, it's everybody who got touched by a neighbor. Throw all my neighbors on a work list. Instead, I'll throw all my neighbors on 3 work lists: the reduce, the monotone, the grow. Now, when I say I'm going to go do the reduces, I'll walk the reduce list and reduce things until the reduce list is empty. He'll keep coming up with new neighbors that got changed that'll go on all 3 work lists until the reduce list is done globally. This would be the new plan. It's not what I'm doing now. It's the new plan, and I like it. The end result being that the program is first reduced before you start doing monotones, before you start doing grows. And that monotonicity means that many of the rules that you have to handle to be, I want to say, one-step Church-Rosser, to be, it doesn't matter what order you take things off the list, like you canonicalize first. And because you're canonical, then you don't have to deal with this one does that thing, except it's dead. And so I'll like my load through fees, if the load is dead and I push it to a fee, now I have 2 loads and a new fee, and they're all dead. And it's more work later. No. Get rid of the dead stuff first. Then don't optimize it. Then go to the next step. So still incremental, still keeps the same running time, but you clean it out first, and that makes it easier to bug before you go to the next harder things. Like the monotone ones are all a little more tricky because they have to preserve some downhill property, or you'll monotone forever. You'll endlessly spin cycle. So you have to know that you're decreasing something every time you do a monotone transformation. And like that load one we're talking about, that's strictly a grow operation if it's done just like blindly. You get more precision in your flow analysis, but you add a node in the graph, and you can go hog wild and just explode all things up through fees and get an infinite number. So I generally tie all my grows with a profitability heuristic that is in some way monotone downhill. So I quit doing the grow things after a bit.
Right. So you said that the heuristic you use for that one is that it needs to have a store on the other side of the fee that is with the same memory.
Or it's going to produce a constant. Or otherwise one of the loads goes away. So let me go see if I have source code for this just lying around. Like I have this old version of Hotspot this is all unchanged since forever.
Yeah. I kind of want to show this one little graph rule, so I've actually got it here.
Yeah, go for it. Do it.
I thought this was kind of cool because it actually does that whole fairly large pattern that we were talking about, and that whole transformation is just this piece. So basically I've got an and, so I'm doing 3 rules here and then capturing the this here. But first I'm looking at the arguments of the compose that I'm in. And I just want to say that all of the selects are selecting a store. And so this is the thing where I was saying, well, I need to figure out how to do that better, but
Oh,
so it's a selecting a store. So I just have a little predicate up here that's just saying it's a select, and the select points to a store.
Right, but you're, oh, okay. Yeah.
And then the next one says, okay, this is what we're looking at is a compose, and one of the select is a select store, where the specific store is this one. So it sort of captures everything before and after, and then here's the one that we match. And it'll sort of iteratively work through them and see if it can find something. And so one by one, it binds store here, and then down here, it does another rule where it uses store, and it actually finds a load, and this is a predicate that says I was able to do a shortest path from the load to this store through the graph, and it's a little here. So I have this
I
path
can't read
from.
closure enough to say what shortest path means. Is fine.
Yeah, so it's just an algo shortest path. It's using the usedef edges, and it's, this is just some implementation detail, but it's just a graph algo doing a shortest path on a graph. So that's what this call is here. Right? So it takes two functions. So one to see if I've found the thing I'm looking for, because this is not like the most efficient shortest path algo. And one that just gives me edge weight, which I don't care about. So it's always one. And so I just do a quick shortest path using sort of a lower level tool. And so basically that was the thing where I was saying that I need to search up through those ads to find the connection from the load to the store, to be able to say, oh yeah, I'm loading, I'm doing something, I'm storing, and then so I can move that stuff that I was doing into a loop. I'm going to replace all this stuff with what we talked about, but I just was quite proud of how cleanly this fairly complex rule came out.
Yeah.
So anyway, that's it. And then I just do like the transformations that I sort of enumerate here. Change this, change that. So
I was
that's
looking
not
for
as
the
interesting.
hotspot code here, split through fee,
I'm gonna
which
stop
unfortunately
sharing.
has all the value heuristics. Let me go find this guy.
So I set up the continuity camera thing on Mac OS. I don't know if anybody here has got a Mac and has tried this thing. So I'm using my iPhone as my webcam. It works amazing.
Oh, that's interesting. Yeah, I'm
so
sure it's much higher resolution than my webcam.
It's way, like, it's such a huge improvement versus the old camera. I can switch cameras. Check this out. It's like a pretty noticeable difference. Plus my screen is over there.
Yeah.
And so just flip back.
Yeah.
Yeah, my vote's for the phone.
Yeah, totally. And it's nice to finally have a phone that's like on my screen. It's just like an inch from the top of my screen.
Well, Hotspot has the code for splitting the load to a fee, but it's not easy to read. It's tied up with an older, grottier implementation, and it's also got the profit heuristics all wedded through it. So
yeah, but I really have been enjoying going through and reading that code, because you may say, I think it's hard to read, but try reading the V8 source code. That's impossible.
Okay, good.
I failed at reading the V8 source code.
Yeah, I couldn't even find anything.
Yeah, okay.
So yeah. So it's really, I don't know how they split it up, but it's very confusing, and I gave up.
Let me see if I can get on I don't need chat anymore. We use Discord. Maybe I'll throw this on the Discord. It's really, now I got too many windows open. I can't find anything. Fine. Let's see if I can actually edit this. Edit message. We will, backtick. See if he's gonna let me do that. Okay, done. And then he gives me a bad thing. And this is. node.cpp : what line number here? 1257. Okay, there's a reference.
Okay.
If you're looking for it, but like I said, it gets a little uglier, but you can see the bones of it. I mean, he walks through and he looks at the region because he's doing a profit heuristic, and he says you're stable. So he's not looking at a loop, he's just looking at a region. He cleans up some other stuff that's happening at the same time, so he's doing other things. He's also looking for other things that are going to optimize first and with higher priority, like you're dead or you're going to be a constant anyhow, and I don't care anymore, and it just hasn't happened yet. And then he finally gets around to like, oh, okay, fine, I found you, you're the right thing. And he clones the fee, the memory fee, makes a new fee, and then he makes the new load, and then he stitches all the edges together, and it's kind of a pain in the neck, and throws in the types. The new guy has to have the new types based on those new inputs and stuff. And
Yeah.
I have a much
Does it
cleaner
have to
version
be
of that in
retyped, or do you just copy the types over because it's the same, or do you just start from top or bottom and redo it?
I think in AA, I copied them over. So to interleave these kind of transformations with a monotonic upwards lifting, constant propagation, you have to carry the types through that you have. So,
Yeah.
Oh, look at this. Thank you very much. I have been granted a homemade waffle, maple syrup and butter. Oh,
That sounds good. Okay, so I found this code. It's on line 1450 in the new implementation, or in the latest version, 1490.
Yep.
That's
Okay.
same idea.
Yep. Well, it was a JDK 7, so I'm certain they've had things happen between 7 and 17.
Apparently 200 lines of code worth.
All right.
Yeah. Yeah, the heuristic stuff is something I haven't really looked at all.
Yeah.
But, yeah.
In the case of the growing optimizations, the heuristic rapidly turns into a correctness. If you fail, then you endlessly grow and you never stop compiling.
Yeah. I can, okay, so I think we've covered that. So the other thing that I did, I've got my call site stuff fully implemented now. And so I basically took your advice on splitting the call site into a launch and a landing, and
Okay.
Split the region. So I have a new region when I do that, and I land in the new one. What I actually did for this though is I made it so that the control flow actually, so I have 3 phases in the life of a function in my graph. I have the build phase where I just have a proto call, and I have proto do call, and then proto call return. And those are kind of the dumb version. They just connect directly to each other. And then I do an expand call sites. And in this one, I do the sort of full graph that I think is best for optimization. And then after that, I do prepare for scheduling, and I bring it back into a simpler representation where the control flow is straightforward for any functions that survived optimization.
Right.
And then, in the in the main version, which is with the constructed call sites, I actually have control flow go from the region that's calling into the call function, then to each of the functions that I'm calling, and then through the function, and then from all the returns through to the call return. And then I have a control projection out of that. And so then for any call that is only called once, all that stuff goes away. It just inlines itself.
Right. Yeah. Right.
And then also I move all of the arguments off of the call, and I just have them floating on their own, so that any fee simplifications can happen and the call can get rid of any arguments that are constant. So like, for instance, if I had lots of different calls to something,
Yeah.
but I use the same arguments everywhere, it all goes away.
Mm-hmm.
And also if the function returns a constant, then everything goes away. So this is the idea, at least.
Right. This is like desperately asking for a graph, a viewable for audience.
Yeah,
I
I
have-
have one. It's a
I
bit
have
complicated.
similar things, but I don't have an easy way to flop a graph up on the current AA code base.
Yeah. I have a graph here. Let me
Do you have
try.
first class functions?
Yeah.
Okay, so do you know what your call graph is?
There may be a fee, and I may have multiple candidates, and I just wire them all in.
What I mean is first class functions, I'm handing you a function pointer,
Yeah,
I'm gonna call it.
yeah,
What are the target functions that get called?
yeah. So ultimately, my belief is that if I look up through whatever fee structure, I should ultimately find it, especially because all of my call sites, everything's wired up in this way. So basically,
Okay, so
it
in
turns
general,
into one
that
giant.
can't be true unless you have some other assumptions that limit who can call whom.
Well, I don't have foreign functions or anything. So
Oh,
everything
Okay.
is in the graph.
Yeah, okay, so I take all function addresses, all functions, I throw them in a big array, I pick them at random, and I call them. So I pull a
I
random.
don't have
index
arrays.
I'm sorry?
I don't have arrays.
I throw them in any arbitrary structure like a hash table, and I pick one at random and pull it out.
So I don't have those structures. The only structure that I have is a predefined structure that immediately gets split up in, so like I can refer, I can do like dots, x dot y, where x is a structure maybe passed in as an argument.
Right.
So my idea is that reference moves up through fees
Yeah.
and then eventually gets fully resolved, but it
Okay.
may turn into lots of things. And so everything becomes concrete references all the way through everywhere.
If you go through an arbitrarily long path of loads and stores and memory references, right? I mean, no arrays, I'll just work around by saying I have a struct which has fields called F0 through Fn, and a function that says, given a random number, report back the Fnth field. And so you have a giant fee merge at the bottom of this, which reads once from every possible field. All functions are now in that fee. All calls go to all functions. Your call graph is a complete interconnect, and that's okay with you.
Yeah.
Okay. And that's because you have some limitations on where they come from. Like in a large functional programming language where you have million lines of code, you're going to have tens of thousands, 100,000 functions. Without a call graph, everybody calls everybody.
It wouldn't be good.
You can't drew that in a graph directly, or you drown yourself. The n squared blow up.
Yeah. So I don't have that. But anyway, it's even if I did, I'm not replicating the functions everywhere.
Right.
Everything it's just a handful of it ends up being like, you wouldn't want to try and traverse the graph because everything's going everywhere. It becomes very dense.
Yes.
But it just is it would just be a lot of nodes, and there'd be a lot of fees, and
no, that's a fine answer. I was trying to sort out where you went with that, and one of your answers was you say first class functions, but you have very limited notion of what's going to be first class, and some small malanalysis will restrict them to what you can analyze. Some guy said I wanted to do a map of this or that or the other, and there's only 2 choices or 3 or whatever. So the don't blow up really quick.
Yeah, so I'm hoping to survive without any fancy data structures at all, because the type of work that we're doing in the machine is fairly limited, and I just
Right,
don't
right.
see the need for
Yeah,
even arrays or hash. I might need arrays in the end, but I may restrict them to
not have function pointers.
some subset of functionality.
Yeah, yes, just
Yeah.
don't put function pointers in arrays.
Yeah, I mean, I suppose you might be able to store a function, but even then, yeah, I'm not sure. I could maybe come up with something that's really nasty that would break the compiler, but you know what? I don't care that much.
Okay, fine.
If someone's like, I did this insane thing and I broke the compiler, it's like, okay, well, too bad.
Right. Right, I get it.
So
Your use case is primarily ML, right? Don't you need arrays?
it's primarily controlling ML programs, not doing ML. And we have a chip
This is the
with,
control logic. Okay.
yeah, exactly. And it's a chip with many hundreds of individual controllers, each controlling their own little bit and communicating with each other and sending, packets around and stuff. And so there's a bunch of complexity in there in terms of dealing with, mailboxes and whatnot, some of which I'm still not completely sure what I'm going to do, but
This is
the
probably for
actual
another day,
code,
but I wonder if there's anything you can learn from H2O in that architecture.
probably, yeah.
There probably is, but he's got a different set of problems. So the main
Yeah.
thing I would claim that would directly hit you is memory bandwidth and compressed data work well. You should have on-chip memory bandwidth like out the wazoo, but it's still,
Yeah.
I mean, unless you're basically treating everything like L1 cache, that's probably still a benefit to think about the compression strategy on data.
Yeah.
So how much of the compression
memory
stuff is
bit-
already taken up by the smaller data types generally used in ML? I don't know.
Well, that's the main hack that H2O came around, was that if you had a two-dimensional data table like thing, calling compression fucking works amazingly well. And even when somebody said, I went to bytes, usually H2O went to bits and or run length encoded bits and got it another 2 to 4x smaller. And that just turned into 2 to 4x more data through your memory bandwidth pipes. And the decompression on bits and bytes is all 1 and 2 clock cycle shit.
Yes, certainly for the training data, that still might be useful, but the weights, it might be a little too high entropy too.
If you're only doing neural nets, you have one kind of set of problems, and your limits usually the neural net calculations and not memory bandwidth. If you're doing a random forest, you're doing a generalized linear modeling, you're doing any number of a dozen other things, you have different sets of problems that come around, and bandwidth becomes an issue. If you have a large data set you're shoving through a neural net and it doesn't fit on your on-chip memory, then you're back to having memory bandwidth. If you have a very large data set and you want to make a reasonable neural net that won't fit on one GPU, then you have to have the weights passed between GPUs to have the models reunify periodically. And if you don't do that, the models diverge endlessly and you'll never get a coherent model across all your data. And if your data is too big for, the one coherency domain that you're doing your modeling on, and you do as a separate series of models, the end result is that you suck because you lose all long tail distributions that are only visible when you look past the data that fits on one node. So that's sort of, big picture, big data thing from H2O. If you're doing a GPU and you have compute power out the wazoo and bandwidth for whatever fits on the GPU, then your models, either you have to do the cross GPU thing, which is complicated to get right and requires, rapid renormalizing the divergent models, which is what H2O did on x86 cores and shared memory machines, and actually in distributed clusters. Or you want to jam more model data in your GPU, and again, compression is your friend because you can jam more model data in. And you're saying, hey, I go to bytes. I'm saying, yeah, if you went to bytes, go to bits. And you get another 2 to 4x compression, and that means you get 2 to 4x bigger data. You can to do your work on your models. So that's ML and data size things. You have I'm gonna say you have a different thing. Once you got your data down to the point where you're running the algo of whatever choice it was, somebody has to distribute it across your cluster, and then the one control unit walks with his own personal pile of data, and then he has to merge results with all his neighbors.
I wonder if H2O would be useful for us on the runtime side to actually feed the accelerator faster, because that's an area that I've seen a bit of struggle where the runtime is just too slow, and it's using too much memory bandwidth. It's killing the.
We optimize the crap out of it, and actually H2O does GPU support these days, so there is a path to take it from wherever it came from onto a GPU and back out. And if you have an interface that's GPU like, you could do that, and it's open source. You could go grab a copy and fork off and do your
Okay. Yeah, I think I have to look into that, or maybe I sort of get the team looking at that, because the
actual company's kind of gone a different direction, and they're trying to do sort of a one-stop push button for naive data scientists to go make something happen. But the underlying engine,
are they on the
training
side or the inference side?
I think it's both. It spits out the code to do the inference like post.
Once we build a model, we'll spit out a high performant Java bytecode, JV bytecode, to go do model execution.
Okay, interesting.
And the model execution can be fed yourself with whatever you do because you didn't compress, or you can feed it from an H2O compressed data set internally and all that kind of stuff. Like we'll take model feeding data and hand you a model, and you can stitch it like it's already expanded into full size ints and longs and doubles and floats, or you can feed it like you're handing me a bulk data set. If I'm doing on the fly, real time, sort of low latency guessing at stock trades or credit card swipes, and I have one API for that, and then there's another one that says under the hood I already took a compressed version because I'm actually doing back testing, and I have a terabyte of credit card swipe attacks, or a big bank will do a terabyte of trades in a day, and you're doing compliance testing on it. It's already compressed by the H2O engine, so you're just running it through the model.
I'm just looking at the H2O GitHub. Is it H2O-3? Is that it, or is
probably
it
3 now? Yeah.
Okay. There's a data table, and which something about being Python, even though the language says it's C++.
So H2O is in Java. It has a kind of an interesting interaction with Python. You can use Python to drive it directly, where basically you're using Python expressions, but you're using H2O as the bulk array math computer. So you can have a laptop on Python and a terabyte H2O cluster, and you can refer to it names in Python, have the H2O cluster do the math. And you write expressions in Python that are limited, obviously, but they'll do the whole terabyte at a chunk. There's no direct C++ in H2O. There's probably a bunch of interfaces to GPUs that is probably possibly C++, but not the core slamming math around the left and the right, up and the down. That's all Java.
GitHub gives you this little language breakdown, and there's no C++ mention, although there is 2.1% other. The funny thing is it's 35% Jupyter notebooks.
Those would be examples. And I don't know what they count for source unless the data sets go into the Jupyter notebook.
Jupyter notebooks blow up to enormous sizes, so it's not surprising.
Yeah, so there's a bunch of examples of Jupyter notebooks, a bunch of examples in R, other languages. There's R, there's a bunch of documentation crap that's not Java that's in there.
I'll look at it, but I have to finish this compiler.
Right.
I can't get
I basically, whenever I've used H2O in 2 or 3 companies since leaving it, I basically have to take their build set and like strip it out because they did a lot of stupid shit that it takes the build forever. I drop the build time down to like a handful of seconds, well, under a second typically. Okay. And then I go make a top level driver. Oh, look at Heinz is in. What the hell, Heinz? Put a top level driver to go, go do the thing I want it to go do, which wakes up and goes, gets, fintech data from wherever and starts doing its thing, what the hell you're doing with it. The normal H2O startup gets you into like a clusters up, and then you attach to it with a browser and you get a GUI and a poke. And maybe that's a little better these days. It was decent when I left, but it's been a while and they could use some love. And they did the love. It appeared pretty decent for exploration. I wouldn't claim you want to do hardcore data science that way, but you could bring up the GUI and like find a data set on disk, suck it in, hit the, I'm going to do a generalized linear modeling as the first easy, one, because it's fast and it's cheap, it's understandable. And it'll immediately tell you that your column that you're trying to predict was in your included data set and in some other way, and then, so he just guessed on the answer and got it correct every time, and you'll have to go fix that. And he's got all the thing, all the bells and whistles are in there for every kind of serious algorithm. All done sort of right way and distributed in parallel and scale out and yada yada, but it works great on a laptop and fine.
All right, this is great. I'm gonna have to spend a lot of time looking at this, and that's gonna have to be after I do this. Otherwise, I'll never get either of them done.
Yes, exactly. Yeah, this is a whole other thing.
Yeah.
Hey Heinz, long time no see. Yeah,
So
he's on. His mic's out. It's fine. I don't know if he's here and he clicked the button by accident. Doesn't even know time.
Pulled up the call site graph, right? We were talking through, so I can show this if you want.
Yeah, might as well. I need to get my own version of the call site graph up, and it's not complete, so I haven't been throwing pictures up because I'm occasionally I'm rewriting it. Yeah, because you get this kind of a zoo, and I'm like, no, we can do something simpler.
Yeah, exactly. So this was my worry, and I hesitated implementing this for a long time because I was afraid it was too complex, but in the end the implementation wasn't too hard and I was pretty happy with it. So like, here's the program that we're doing here.
Yeah,
it's not much of a program.
Yeah, complex
Right, so
is X plus
complex
B,
is
okay.
very complex, as you can see.
Yep.
But it's doing, so these are globals, so that's complex for me because I was doing global stuff there.
Okay, fine. Yeah.
So okay, so basically I call this, I call that, that's it, pretty easy.
Yeah, right.
So it turns into this. So I've got so the other thing that happens is that this gets moved into a function called init namespace.
Okay.
So there's an init ns function that's in there, and then the program is started from a program called a function called init program, and that's one that's not callable, but it exists, and so everything's a function.
Yeah.
So so it ends up with the memory, and then it wires up the arguments like this.
Okay, so graph layout things. I know select and compose are separate for you, but they are tied together semantically. I would encourage you to,
yeah. This is something I started doing later. Yeah.
I do this with my graphs now too. Like your call return in the middle left there has the projections underneath them, and they are tied to the call, and I do the same thing. I learned that from you. I just forgot to do the select here. The other good thing that I discovered is that if I have columns in the graph which represent different states, it actually comes out quite nicely. So like here I've got a column for everything memory B, here is a column for everything memory A. Right. So another suggestion would be to put a box that is no part of the graph, but a bounding box around the function simple x, so that naive readers who don't know what the hell they're looking at can like stare at that and say, oh, here's the regions for simple, and I can pick out arg x1 plus return. Oh, that makes sense.
Yeah. So in fact, I've color coded them.
Yeah,
so
I'm seeing
yellow
that.
is
I'm trying to break out do call from call here. And I call mine call node. I don't node everything. I have a call epilogue and a call prologue instead of a call. But same thing.
So yeah, I have do call and call return. In fact, I changed this to call from.
Okay, why does args have an X? In this region simple, purple region simple, Oh, okay, and then, yeah,
Here's-
that's region complex, go to region simple. Region
where
simple
is
is
it?
above there, it's purple.
Here.
Yeah, args, I would say that's some set of your args, which would be a fee for every call site. So it would be
Yes.
a compose and a select.
So it is a compose and it's got a select here.
Well, what's the X then?
X is the name, arg name.
Is that in the graph?
No,
Oh, we'll get rid of it from the graph picture.
sure, okay. So this is actually a compose.
Yep. Right,
Uh,
compose. Now put a
um,
little X off to the side of the compose to say this happens to be the X variable, but that's a
Yeah, yeah.
compose. Yeah.
Okay,
And for me, the compose I call a parameter or parm, but it inherits from fee. So it's actually a fee node for me. Just same as you have a
Yes.
select and compose, I have it's just a fee node. It happens to have an
Ex-
argument name for debugging purposes only, no semantics on that argument name.
yeah, that's right. And so, so for me, I have compose args, but I don't have an inheritance hierarchy, so I just treat them the same, except when they're not. So that works okay. So I just sort of select for compose or compose args when I'm matching stuff. When
Oh, I see.
when it's
Yeah, I'm trying to
So-
decide if my parm nodes do anything terribly. Yeah, the parm nodes have a few things they do different from fees, but not a whole lot.
yeah, not a lot different.
Just a second, let me mute here for a second.
Mhm.
So Simon, I see you dropped something in the doc.
Well, it's some
Sorry.
optional things to
Negotiating another
talk
waffle.
about, but
Oh, did somebody do something in the docs? What did you see about the docs?
Oh, Simon's got an update he wants to do too. I actually have to get out of here at 2:30, so
Well, why don't we let Simon have a go? Like no docs or update. Oh, there's some docs. Somebody did an update on docs. Yay. Okay, fine. There's at least, yeah, no offset mention. Yeah, fine. We're missing Teodor here. He always does a good job. Yeah, let's go do Simon's thing here.
okay. All right, I will stop share. But thanks for the help. It's gonna be good. Change
Yeah,
that.
I'm having fun.
Yeah, so am I.
Okay. Hey, Simon, did you want to go? I see you've got a bunch of
Mm.
stuff in the docs, so that's like.
sure, I have some smaller things to show, or at least present some thoughts on it if you're interested. Shall I share?
Yeah.
Mm,
I mean, I can read the docs, but whatever. I'm sure it's easy to.
let's
I may stick on reading the
like
docs.
this.
Oh, okay, there it goes.
Work.
Yeah, I'll read the docs because I get a larger font.
So well, let's see whether I can zoom in. No idea. This. So last week I showed a few things that were already done. I have some follow-up things that I'm currently working at, and I think the first point, optimizing keyword length a bit, was already discussed in our channel, but I think if you're not only trying to optimize for length, but also for meaning, I think I'm warming up to using union instead of enum and value instead of struct, because it feels like, at least in the struct case, it's a term that came from C and C-derived languages, and it has a lot of baggage, and it feels that it implies mutability and a lot of other things. So yeah, I'll give value a try. I mean, it obviously clashes with using the word value in many other contexts. For instance, when referring to an instance of some class or some value type, but
Like in your.
let's see
Your
how it
field
goes.
bundles are not mutable, or
Sorry?
whatever you call your field bundles, they're not mutable. Like the structs are mutable.
No. Yeah. So yeah, so basically value types are immutable, bit like they will be in Java in the future or in some other languages. So it feels that if you're really chipping away uh, the meaning until you arrive at the core, I'd say it's a value like, for instance, an integer is a value, and putting other things under this description, for instance, a point containing two float values is also some kind of immutable value. And yeah, a bit concerned about the conflicting uses we currently have with value, but I'm interested in giving it a try, and then I can report back on the results.
When you use this valued keyword, is that just namespaces, or would a indexed tuple also be using the word value?
Yeah, index tuple in the sense of indexing with
Where it's just item 0,
number.
1, 2, 3, rather
All
than named
right.
items.
I haven't really decided. In the sense you currently can make up tuple values out of thin air by just putting parentheses around multiple values. So there is currently no, let's say, no real definition of a specific tuple. So I think I can postpone thinking about this for some time, and maybe I can get even rid of tuples in favor of just finding names for specific users. Of course, you will probably end up with having a pair or some kind of entry or some kind of key value that's still generic, but yeah, how often do you use tuples of size 4 to size 20, or let's just say tuples above size 4 or something? It's minor use, I think. So maybe it's possible to get rid of that. Yeah, that's so basically I try to have all my big shape keywords have the same size, and Impl I haven't really managed to do anything about this, and the small shape keywords are already all the same size, and I'm currently not planning on pushing this any further, so I'm not doing, for instance, case then else instead of if then else, or if do or instead of if then else, and similar things that would be possible, but where I say, well, maybe that's not worth it. Yeah. In other
Like your-
news, sorry?
I like your if is pattern matching.
Yeah, that's coming along rather nicely. I still have some issues, especially as I worked on semicolon inference at the same time, and sometimes I'm really confused. Okay, is this not parsing because my semicolon inference is not perfect yet, or is this not parsing because that's part of the pattern matching enablement that's on another branch? But yeah, the interesting thing is really that with match over here, you basically indicate that you're pattern matching on foo for all branches, and the match keyword has an effect on everything in between the curly braces. And if you're doing pattern matching inside if with this is keyword, you can selectively choose which branch you're pattern matching. And for instance, there could be a third possibility or something where you're not pattern matching, but checking for some different condition. And I think that's nicely because we are pushing
What's
this
the
pattern.
what's the semantics of that? It's just
Mm,
guarded tests after that. Like you're doing pattern match, we could do guarded tests as well.
that's true. Yeah, I mean the semantics are still a bit unclear. You can do if Let's grab some of these copy things here. And then you can do if foo.
The Google later will capitalize you.
If foo is bar, then you can do something here.
Yeah.
But you can of course have other branches where you say, for instance, foo equal or foo dot value equals
Yeah.
test. So that's still possible.
So that could be-
And on the topic of
well, one of those is
doing
if you're doing pattern matching, the assumption is the compiler breaks it out and chooses which pattern is going to win. Emits code to pick which pattern wins. And if you're doing guard tests, he runs them in order given until the first test passes. And then he walks away with it.
Yeah, that's basic.
Okay, so the semantics are a little different because one says there's no order to the tests. I simultaneously test all patterns. And I pick the one, and the other says, do a test, do a test, do a test, do a test in order. Tests have side effects, tests have dominating and non-obvious patterns and stuff like that.
Yeah, I mean, it's still the case that we are relying on order, that we are testing this branch before this branch. And of course, this opens up the question, okay, how do we check exhaustiveness and all the other questions you usually have with pattern matching, plus all the questions you usually have with if expressions. For instance, do you need an else branch, or is are the checks before a potential else branch exhaustive, so you don't need to write the else at all? And yeah, I haven't really figured that out yet. And if it especially also if you're doing further binding inside the pattern matching, it's always a question, okay, I have bound X there, can I do this, for instance? What about this, and all the gnarly details
The
that will be.
X is some other conditions totally makes sense, but the
Yeah,
or-
exactly. So you basically have to have some subset of your language that you are only allowing there. And I'm really uneasy about that, but I haven't really found a better approach. I mean, some languages really make it obvious that you're using some kind of sub-language inside a pattern match.
Right.
Since they have like these discards where you do if directly in here, but I really want to avoid that.
Well,
So yeah,
guard better not have a function call, or you don't.
Isn't the thing that like you have the pattern match, but then you can have a kind of guard clause on the pattern match that then says, if I do the pattern match, then now here's some irregular code that you want to run, and it has to act like a predicate and return true. Otherwise, I don't know what your rule would be, but I guess keep on searching.
Well, it's semantics, right? Supposed to say foo is bar and you let X and function on X, then okay, I'm good to go. Okay, what does function on X do? What does it have side effects? Like right, predicate X. Okay, what if predicate X is a function has a side effect? Now, is that test? I mean, there's an obvious top to bottom now. So if I then follow the is bar let X, I have another one that says is foo, is baz, whatever, and you would think the patterns would pick only one. But if they all have predicates of various kinds of side effects, then you're back to the I'm doing these tests in top-down order or something. There's some semantics you need to give to the side effects, or disallow them by saying I can't have a function call. I can and any arbitrary expression that has no side effects, so no function calls.
Does this
language?
Does this language have the ability to identify functions as pure or impure? Like,
no,
that's another complicated thing. Yes, you could.
Yeah, I mean that's a question of if saying, okay, if this has a side effect, are we trying to be smart and say and recognize
I wasn't going there,
Uh,
but yeah, you could go there.
this is like the same call if I evaluated this
Oh my
over
God, no,
here?
no, no.
That's like an
Should I
optimizer
assume
thing.
the
No
same?
semantics on that one. That's an optimizer. The as if rule applies. The optimizer might cache the thing or
Yeah,
not, but no
but I-
semantics.
But I guess in these cases, I mean, it would be very unusual that it would. I mean, the example would need to be very contrived to say, okay, I have a predicate and I somehow cache the results of this predicate and reuse it. I mean, you would have to do
No,
something
something
like
don't do it.
this and
Mhm.
to even get to the second line. But yeah, that's probably for another day.
Well, I guess what I'm saying is, as soon as you put the function call in there, you have basically a series of arbitrary code being executed line by line. You go to the semantics of, I test them in order, and the optimizer does what he does. And you don't have an exclusionary at the end. You need a default here in case, foo is a bar, but the predicate's false. You still need a default case.
No.
The semantics that come to my mind would be that just like the dot value equals whatever, that's a regular sort of language semantics, and it has to happen in order. So under the hood, I would imagine that any pure pattern matchers have no ordering, and then they can be sort of grouped, and then you have sort of an else, and then you have a pattern match that comes next in order, and it's matched, and then if it doesn't match, you've got an else, and then if you have a bunch of pure pattern matches after that, they can all be unordered, and so you sort of like end up with this nested structure that's like happening under the hood. Person doesn't have to write it, but so it's like I have some unordered matches, I have some ordered stuff, some unordered stuff, more ordered stuff, or whatever.
Yeah, I mean, allowing arbitrary expressions in there makes it harder to basically optimize the flat list of cases into some decision tree where you're only computing things once. So yeah.
And then as for
I
for completeness, like, wouldn't it be enough to just say if you do any of these like non-pattern things, then you have to have an else?
Yeah, exactly.
Like
I mean,
the user?
you can't, as soon as you have stuff like this, basically all the exhaustiveness checks.
They're
I mean,
impossible,
you can have heuristics and you can have good heuristics, and some languages do exactly that. But I think it's just yeah, you can basically sink unlimited time into this, figuring out whether your pattern matching with additional arbitrary expressions are still exhaustive or not. I mean, yeah.
But isn't that like the halting problem level of thing?
Yeah, exactly. I mean, there is no general solution. You just can push the ball further. I mean, you can say
Why did Google did? Well, there it is.
can always say if x and
I just don't know if it's like useful.
x smaller 0, and then you can have another branch saying, okay, x greater equals 0, and then you can argue, well, these two make at least a bar case exhaustive,
Right.
but it's always just heuristics.
Below where I specifically said predicate and then question mark colon to force the obviousness of that, like replace my pred x here with x less than 0, and here's the x less than 0 case, and here's the not x less than 0 case, or same thing as x greater than equal.
Yeah.
And I don't know if that's any better or any worse.
Yeah, I mean, you could rewrite this to just
I was trying to not
just,
have the compiler attempt to invert x less than 0 and x greater than equals 0 and determine that they were exclusive and covered the entire space. That was always like that's a dangerous. Here's an arbitrary predicate, and the compiler's going to invert it. No. You need an
yeah,
else
I mean, you
clause.
could,
Yeah.
you could
What if you know it's like something
Yeah.
equals not a number?
Oh God, yes. Well, that's why the else. So as soon as so now put up an else. Sorry, Simon, put up a syntax where you put the dots and the interesting stuff on separate lines, which in my head is one of the goals of doing these pattern matches. You do a pattern test. If you
Yeah, I mean,
match, you
like-
have a one-liner of what it is, and then the next test and a one-liner of what it is. And that's what your examples originally look like. And that's sort of a clean thing to do. As soon as I have a predicate in there, I have two different things for the dots. And in the case that you just wrote there, you put them on the same line, which is totally semantically equivalent, but it loses out on the usefulness of seeing that I have a series of independent things that are only one will ever execute. And I've got them one per line.
Yeah, it makes it really complicated in a sense.
Yeah, right.
It makes it really hard
I was just
to
throwing out a test version answer.
to
Maybe I'm a
see,
little
Sorry, I have
too.
I have to drop off. So it was fun, but talk
Yeah.
to you next time. Bye.
Oh, hey, just so everyone knows, I'm going to throw out on Discord as well a general thought of opening up the Discord channel to more folks who don't make it onto the coffee club list, but are like interested and can talk offline times, but Friday at 10 a.m. California is not what they can deal. And does anyone have a preference? Like, don't invite the universe in, do invite the universe in for read only, moderate heavily, and then there's the programming languages Discord, for which we would fit in with them, except there's a much broader spectrum of the level of understanding and experience of people, and so you'd get the programming languages channels that do this kind of things are filled with wild variations between real skill and real noobs. And here there's a more cultivated set.
Just a thought, like you have this nice clean group in the current Discord.
Yeah.
Why not create another group, try it out, move everybody there, and then if it doesn't work out, everyone can just gradually migrate back to the old one and without kind of any too much chaos.
Okay, so yeah, I'm hoping that Discord would let me do things like invite a broader audience for read only, and then I'll case by case invite people in, just like I would for Coffee Club. Make sure they're sensible people and that they do things with compilers, and it's not a Pornhub spam or whatever. And then the other one floating around is that Discord does video. I don't know if it's nearly as good as Zoom's. Zoom's video is decent, but if I get to Discord video, I can drop one of my tools I have to deal with, and we have a single channel for communication, and because the Discord chat box is active.
Can you record the Discord one?
I have no idea.
Yeah,
I can go explore. If people have experience, I'd love to hear it.
I don't know.
So
I have
just
to
be
run,
aware,
so
I'm
sorry.
looking to either allow more people in or get more folks involved in the Discord, because that seems to be very active and very easy for people to get on and do things with. And if you have an opinion, just tell me however you want to tell me, email, private Discord, private tweet, whatever. But the obvious thing here is I'm looking to divorce myself from Twitter in case Twitter collapses. Like, I'm not going to walk away from Twitter, but if Twitter collapses, I want to have a in place.
Hey, Cliff, you asked about recording, right? I think Brian Cantrill is moving from Twitter Spaces to Discord too, so he may actually try this out, because I remember he was always recording his Twitter Spaces. So
Okay.
I guess we can just watch what Brian Cantrill does.
Okay, well, I might reach out to Brian then, see if he likes the experience, or I might try it not yet, but I'll get some announcement, but I might try a Discord video sometime and see if I can, if it works with 10 people on. It's 10 to 15 seems common when I'm not holidays, and it all works. But yeah, could be there. And then won't have a chat box, and the Zoom will just use the Discord chat, and so on and so forth.
Yeah, I mean, that's currently it's like the hardcore group that's skipping Thanksgiving or something in the US.
Yeah,
Can
yes,
someone
yes.
put the Discord link in the Google Doc or something? 'Cause I haven't joined it yet.
You haven't joined the Discord?
No,
You
no,
the-
I must have missed it. I don't know.
I sent it out to everyone. At
Oh,
Coffee.
maybe. Oh, there's an email.
There's an
Is that what
email.
I missed?
Yeah. I'll send it out
Okay.
again.
I mean, I'll find. I mean, I just didn't read my email, I guess.
Yeah,
Okay.
fine. That's one of the other things going on. Of course, I have to go round and round and round and make sure. Let me throw that in the Discord. No, that's not.
Oh yeah, there it is. All right. I see
I'm
it.
unsharing your screen because I'm trying to find. No, I don't need that. Where's the chat button now?
All right.
Here it is. I found the chat. I'm going to throw it on the Zoom chat so that you can grab the link there, Alan.
All right. Yeah. No, I got it. You don't need to send it to me.
Well, I did anyhow.
All right.
Fine.
Right. So shall we do another short one? Then I
Sure.
think I'm completely out of topics.
It's like result,
So,
and okay, and success, and
my-
failure, or pass and fail. Oh, pass.
Yeah,
and
I
fail.
mean,
I posted a
the-
link slightly related to exactly this. So Google in their like standard library thing has a status thing as well, and that is slightly more encompassing because they don't just want to return like a single thing for error, but to maybe distinguish different error types, but not too many and so on. So that might be something to look at as well for inspiration.
So I'd say, you got an error. I'm all about just, and it's complicated. The error just has parts inside of it.
Hmm.
right, so they are using the status things with error codes and stuff.
Yeah, right.
All right. Yeah, well, I'll have a look at
Oh.
that.
Well, look up do your okay thing. This is just a name change.
It started as usual as some kind of name golf. So of course, we have like option with some and none, and those are like 4 letters each. And wouldn't it be nice if result had the same and also 2 consistently lengthed variants? And currently I have okay and error. I considered success or failure as well as pass and fail. And out of this naming discussion, I realized I have this non-definitional enum concept I worked on a while ago. So the core insight there is, do I actually need to have separate variants for option and result? And my current idea that I'm exploring is saying, okay, I have this union of option. This was previously enum, and I'm saying, okay, this option is of either of type sum or of type none, and let's just do it like this. So, and I'm basically
Does it
saying,
matter
okay,
that some and none might be different sizes in memory?
I really haven't thought about this. I mean, over here where you say, okay, none is unit and unit only has a single value, so we are not even having any kind of information we are dragging around. It's of course the next step to say is, okay, we have the sum of t and we have none with no data attached. Let's unbox this option construct to just a nullable reference. That's of course the first step at optimizing this.
Yeah, I don't like your none of E on result because I think it defeats the meaning of none. I'd rather have pass and fail for the result one.
Yeah, and exactly. Yeah, and the idea is, okay, I have this option. I'm using these classes I have defined here for my variants, and can I reuse those classes I used for option for result too? Because whether if I call this sum or if I call this pass or success, the semantics are basically the same. And the none case is really the thing, the question you brought up is exactly the one I'm having. It's possible to share the sum case between option and result, but is it a good idea to also share the none case, or do I want to have
What do you mean
something
by
like
share the?
Like I'm claiming that the sharing there is not helpful.
You
And
said
I would even say, well, maybe, but put the fail there, yeah.
then we could
And then I would
basically
say
do
some would be pass or be okay. I actually like result okay and just live with
I would
the
do done
like-
and fail, because it's not really a pass. You don't necessarily know that something was successful. Either it finished or it gave you an error. I would say done and fail.
wow, that's
Oh,
a,
done and fail.
that's a
Oh,
good
that's a good, yeah, I'm okay with
done
that.
and none. It even rhymes. I mean, from
Oh, no,
the
some and none and done, yeah, and done, yeah.
I mean that's a plus in my book, I
Okay,
guess.
fine. Done
Yeah,
and fail.
so
Yeah, right. Now
yeah.
put the
So
done down on the union down below.
mm,
Not there.
there, right?
No,
Done.
no.
You mean down here?
Yeah, on the result, yeah. The result is you're done, and the option is still some. I got something or I don't. Result is I did an action, the action is now done, or the action failed and didn't get done.
Yeah,
One is a noun, one is a verb.
that's a negative thing, of course, but yeah. And so thanks a lot
So now you
for
just need a
the
word for
done.
fail that ends O-N-E.
Yeah, I mean, but thank you for this done idea. I'm really happy that somebody found another word that might be an alternative. So
Yes.
yeah, that was just my thought. Instead of looking at option and result variance as separate issues, saying or wondering, okay, they're basically
They
pretty
almost
much the
rhyme.
same. They're almost the same. Can we even use the same classes for both of them? And I mean, it would be fun if you have a value of sum, and then you can pass it into a function that's taking an option, or pass it in a function taking a result without having to convert anything at all. But I'm not sure how useful this is in practice. So yeah, that's
Generally, most call chains use one or the other, so I wouldn't expect to need
Yeah.
to convert in.
But I think the question is, are these things using one or the other because they are not interchangeable, because switching from option to result or the other way around is too cumbersome?
No, it's like one's a noun, one's a verb. For me, it was noun and verb. One's a state of being, I'm an option of something, and one is I did an action, what was the outcome? And so I used them in places where I wanted to indicate this is the result of an action. And the other one was just like long-term storage. I got a thing or I don't got a thing or whatever. In my lame, you could just delete my lame, whatever that was.
No, I leave it in there. I will copy this later because I have some more new ideas that I have to
Oh,
ponder.
I see. Okay.
So,
How do you
it's
fit futures
already,
into this?
sorry? I didn't hear it.
How do you
Can
deal
you-
with futures in this nomenclature where something can be done or failed or not done?
I'm not even that far. I mean, we could do a future of T, and then we of
Don't-
course then have to.
Don't get to ask for it's done or not. The act of asking makes you stall until it's done.
Yeah, I
Yeah, but
mean,
you want you want the action that says, hey, is it done yet?
I mean the Scala approach is, I guess, this or something very
You
similar.
also have pending or whatever.
Yeah.
But yeah. Yeah, but
No,
wait,
okay, fine.
wait. We can do wait instead.
Yeah, wait
Oh,
has
sorry.
has a
No, right,
overloaded-
right. Keep it both. I mean, yeah,
No, wait
I
is
really
not like a
haven't.
thing in the union, right? It's like an action that you take on it.
Yeah, but like Like, right, so it's really sum or wait. You don't get a fail out of the future. If the future is going to return an error, that'll be in your T. And I'm just using wait as a none, as a not yet. Like the only options.
Yeah,
on the
that's fair. The
are-
future just
I
gives you
think
a
different
result.
languages went different ways. Some fold expand the error case into the feature itself. Some leave it in the T, and
Okay, I see.
Yeah.
Yeah, I was leaving it in the T here.
Yeah, I think that the core distinction is if your future doesn't support cancellation, I think most languages go with the single type parameter approach that doesn't
Yeah.
that doesn't expand
So there's
the future failed.
there's errors in the execution engine versus errors in the task being executed. Like,
Yeah.
I ran out of memory, or ran out of threads, or I detected a deadlock or whatever, and the
Or
task.
the future was canceled. I think cancellation is really the big
Right.
discriminator. If you have cancellation, you probably also want to have to detect this additional state. And if you are not supporting cancellation, you often roll it into the T
error, the T
case.
and T. Yeah, right. No, that's not a bad answer.
Yeah,
Pending's
I'm
better than
really
wait, but that's
unsure
me
about the
working.
whole thing. I mean,
And cancels immediately more letters.
stop.
Yeah, I don't know. Fine.
Yeah, I mean, future has of course 6 letters, which is preferable because option and result also have 6. But
All right.
usually the semantics of future is that they run immediately, and I think it's a really poor idea. And I prepare these task semantics more, where you first define your task and then you run a task explicitly, either by calling run on it or putting it in some kind of executor.
Yeah.
But
Yeah.
I mean, I'm not even that far to seriously think about these things.
All right. We beating this one down?
Yes.
Okay.
Right.
Anyone else? Go enjoy our day later Thanksgiving turkey. I guess most of you folks are here because exactly you don't have Thanksgiving turkey. All right.
all
Well,
right.
I had Thanksgiving turkey yesterday, but like, I mean, I don't want it for lunch.
I'll tell you got leftovers? Yeah, for yes. Well, usually I have pie for lunch. Then I'm mostly sugared out. I'm looking for some protein by dinner. Turkey comes around. We had fewer people today. Most of my kids are going to show up on Saturday. I have a much bigger group Saturday. So I have 2 different ones. So today we did Cornish hens instead of turkey. And a lot of good veggie stuff. That was fine. But Saturday is going to be a smoked brisket.
Cornish hen
it-
kind of went the other way on that one.
Yeah. Yes.
Thing.
And maybe turkey thighs
Yeah.
done up like
Like
you
the
get a Renaissance.
like Thanksgiving is the national holidays where a whole nation tries to deep fry a
Yes.
frozen turkey
Yes.
because
and the
they
videos
forgot
are
it
amazing.
to leave it out for like the appropriate time before.
Exactly.
Oh well.
Exactly. No deep frying today. I'm hoping for no giant flamethrower turkey effects. I've seen plenty of those videos. It's all good. All right. Till we meet again. So it should be next week. Same, unless you hear otherwise, and I'll be announcing hard and well, it'll be Zoom and Google Docs, but maybe the text will move over to the channel, and I'll throw something on the Discord channel saying, hey, we're pondering this. Okay. Good afternoon, good night, whatever.